All right, so looking at 2, 3 linear function. So a linear function is a special type of function whose graph is a straight line. You've seen probably hundreds of these. You're probably not a huge fan, but they are a very important function because I mean they come up for a lot of different applications, a lot of things you can model with a line. The slope of a non-vertical line through the points x1, y1, x2, y2 is the ratio of the vertical change to the corresponding horizontal change. So AKA to find slope, it's this formula, which hopefully a lot of you guys know, or hopefully it looks very familiar. But you do y2 minus y1 over x2 minus x1 to get your slope, or it's just the vertical rate of change over the horizontal rate of change, or your rise over run. So I'll try and write these. Slope is the ratio, basically what that formula is, of the vertical change over the horizontal change. You can see from over here, we can have a positive slope if your line goes up as it goes left to right. You can have a negative slope. You can have a slope of 0. This is if you have a horizontal line. So this would be like if you had an equation y equals a number. For example, like this looks like it's y equals 2, like in that graph. If you have an undefined slope or a vertical line, that's where you have x equals a number. Honestly, how I keep, I don't know if you ever mix up your vertical and your horizontal lines. How I keep it straight is it's just opposite of the axes. So y equals a number actually gives you a vertical line. X equals a number gives you a, sorry, I think I said that backwards. Y equals a number gives you a horizontal line. X equals a number gives you a vertical line. It's just opposite of the axes. That's how I've always kept it straight as a student. I don't know if your teachers ever gave you a better way to remember, but that works for me. Maybe it'll work for you. Let's look at an example. And I know this might be kind of tough to write. These notes are posted with the key as well if you need them. So I'm sorry if I'm moving a little quick. I'll try and keep up at least the bottom ones. That's what I can fit up. But looking at this first example, we have a bunch of lines in this picture. So we have like lines A, B, C, and D. We want to kind of match up which one's a positive, which one's a negative, which one's a 0 slope, which one's undefined. So maybe just in the chat, which line is positive? Ariana says it's A. Yep, this line here is A, so that is positive. So a lot of people just sent it. All right, someone, what would line B be? What would this line be? That's going flat. B. Oh, I see what you did, Aaliyah. I kind of asked that, kind of weird, but B would be 0. I guess I kind of went a little out of order. Yeah, look, I hope I'm saying it. Is it Labria or is it? Yeah, I'm assuming it's not Labria, right?
Labria.
Labria. I'm saying that right? Okay. But I see what you did. You said the next one was D. D's the negative line. I saw there might have even been someone else, but negative should have been D because I kind of went out of order. So, and then this last one, the only one left is C. Well, that's a undefined slope because it's vertical. So sorry if I kind of jumped in a weird order, but I'm assuming most of you guys probably wouldn't have much trouble with this. Like I said, 2-3 is not a very tough section, hopefully, because it's mostly, it should be pretty much all review. A lot of chapter 2 is review, to be honest. Eventually we'll be getting, chapter 3 systems of equations, but well, there's a couple things like linear regression's probably new, but all right, so we're going to go to the back side of this. Just practice finding slope. So remember, this is your first x value, first y value, second x value, second y value. So that formula is y2, oops, crap, that looks like an x. y2 minus y1 over x2 plus x1. That still kind of looks like, I don't want people to think that's an x. So if we plug in our values, or you could do it the reverse, you just got to be consistent. But if you plug this in, it would just be 4 minus 7 over -2 minus -3. So that would really turn into a positive when you do those. So +3, because minus a minus turns to a positive. So you would just get -3 over 1, or -3 would be your slope. But finding slope, I'm sure you've done it a lot. You probably don't like doing it, but it's not too bad. Okay. The next problem, especially since you guys don't have the handout, they're asking you to look at line A from the front, but I'm just going to give you 2 points from the line because you don't really have the notes in front of you unless you printed them out. But those are the 2 points for number 1. How about you guys try, take a couple minutes, see if you can do question 1 and question 2. Can you find the slope between these 2 lines? Like I said, hopefully nothing too challenging, but it is going to be important. I mean, a lot of things we'll be doing, you're going to want to be able to find your slope. So at least in chapter 2 and 3, while we're dealing with lines. Chapter 4 is when we get into quadratics, so we won't really be dealing with lines in after chapter 4 for a bit. Good. So I'm seeing a lot of people are saying 4 over 2. You do get 4 for the top. Like if you do this for this first one, you should have, so it would just be 4/2, or if you simplify it, would be 2. Which I see a lot of people are getting. What about example 2? Anyone get a chance to try that? So if you plug in your values, good. Michaela got it. Bria got it. You should get -3. And I don't care if you're doing it backwards. I know some people might have done like 5 minus 8 over 2 minus 1. That's okay. As long as you're consistent, you got to either do a y2 minus y1 over x2 minus x1, or you have to do y1 minus y2 over x1 minus x2. So you just got to be consistent. So it doesn't bother me if you write it different than how I'm showing my work, as long as you're getting the correct answer or you're doing it correctly. That's fine with me. But I'm just going off of how they define the formula. All right, so slope doesn't seem to be a trouble. The next thing we're going to do is just graphing. I know this might be kind of awkward if you don't have graph paper, so just bear with me. If not, just follow along. I'm sure this is review, so I'm hoping everyone knows how to graph a line, but if not, the first thing you always want to do is plot your y-intercept. So remember, this is our form. This is your b, or your y-intercept is the 1. The coefficient of your x is your slope, or your m. So our y-intercept is this 1, so you plot that on the y-axis. This is even going to be hard for me. Can I zoom in? I'm going to have to zoom in a little. And I'll use maybe a different color so maybe it shows up a teeny bit better. So you plot your y-intercept, and then our slope is really -2 over 1. So you go down 2, right 1. You can do it a couple more times if you want, but then try your best to connect them. So it looks something roughly like that. We're just going for a sketch today, so especially if you are writing this on like scrap paper without graph paper. But how you graph a line, hopefully review. Oops. Oh, right an extra chunk. Then if you want to try and graph this next one, I know this might be kind of weird to do, like if you don't have the notes printed. So if you can just try and draw your own grid, that's awesome. If not, I understand. Just if you can't do it, don't worry too much. That's one thing I'm going to have to try and think about when we get into graphing. Like I'm going to assign, like your assignments with graphs, I'll use Delta Math because they have it built in, even though it's kind of annoying, but it's better than making your own graphs. That's one thing I'll have to think about if we get into something that's really heavy on graphing. I'll have to try and come up with a better solution. But just for sake of time, and it's not like I can really have you guys show me your answer really quick or easily, I mean. This one, if you graph, you would start at, oops, not there. You would start at -4. And your slope is +1/2, so you go up 1, right 2, up 1, right 2. One thing that's kind of important to know is how to go the opposite way. So if you just do the opposite, go down, left 2, that'll be helpful if we're ever graphing. Oh, that is really bad. Pretend I connected through all the dots and it was perfect. But that's what it'll look like for that one. And that's it for these notes. Like I said, it's a very, very, should be a lot of review. I mean, there's hopefully no one's like, wow, that's some new math to me. I didn't know you could graph lines like that, but I'm assuming most of you guys all know this, so I'm sorry if it's not the most exciting. For tonight's homework, there is a Delta Math assignment. I think I didn't post it though, so let me do that now. It's just over what we did, so hopefully it's nothing too crazy. Yeah, let me post that so it's there. Change the due date. It's today the 14th. It's super confused. All right, so I posted the assignment in Delta. I can show you it, I guess, here.